Hello, dear students. Good morning to one and all. Welcome back to the chemistry class. Class, we have covered packing efficiency or packing fractions in simple cube, body centered, and face centered. In simple cube, the packing efficiency is 52.4%, whereas in body centered, it is 68%. And in face centered 74. Okay, right. Now, in today's session, we'll discuss about the formula of a crystal structure, formula of the compound, and calculations involving unit cell dimensions. Calculations involving unit cell dimensions. So let us first deal about the formula of a compound. Formula of a compound. Formula. Formula of compound. So in this concept, it is very easy to predict the formula of a compound because as we know that in a metallic structure, the metal atom constitutes the crystal structure usually, and the empty space is white. So in case of simple ionic compounds, the larger ions, that is anions, make the crystal structure, whereas cations are present in between the empty space, that is whites are occupied by anions. So let us illustrate the formula of a compound by taking some examples. We can take some examples, and by using these examples, we'll illustrate how to predict the formula of a compound. A first example: a solid is made up of two elements P and Q. A solid, one solid, any solid. A solid is made up of. A solid is made of. A solid is made of two elements. Two elements P and Q. The solid is made up of two elements P and Q. I don't know the formula. Here it is given. Atoms of Q are in CCP element. So here Q forms CCP element. Are atoms of Q are in CCP arrangement. Atoms of Q are in CCP arrangement, while P atoms occupies all the tetrahedral sites. All the tetrahedral sites. All the tetrahedral sites. Full stop. What is the formula of compound? So this is the question. What is the formula of compound? What is the formula of compound? So the solid is made up of two elements, that is P and Q, whereas the atoms of Q are in CCP arrangement. CCP, cubic closed packed structures. As we have studied in the previous class, that in simple cube, body centered and face centered. In simple cube, body centered and face. The number of atoms present in simple cube, BCC, FCC. So here we already know that in simple cube, the number of atoms in simple cube. How many atoms are there in simple cube? One. Number of atoms in simple cube is one. In body centered cube, Number of atoms in body center is 2. FCC, phase center, or it is also known as CCP. In this case, it is 4. And one more structure is there, that is HCP, hexagonal close pack. So in this case, the number of particles is 6. You note this. In simple cube 1, BCC 2, FCC or CCP, it is 4. Hexagonal close pack is 6. And as we know that for n spheres, a crystal containing n number of spheres, the number of tetrahedral and octahedral voids are given by the formula. Octahedral void is given by n, tetrahedral voids are given by 2n. Octahedral voids is equals to n, that is as it is the number of spheres, whereas tetrahedral voids are given by 2n. So this is known data. Now, so come to the problem. A solid is made up of two elements, P and Q. So that means the solid which contains solutions for this P and Q, two elements are there, and it is given atoms of Q are in CCP element. CCP, cubic closed pack structure. That means in cubic closed pack structure, how many spheres are, how many atoms are there? 4 atoms, because CCP or FCC, the number of sphere n value is 4. So number of octahedral voids are same as number of spheres, because octahedral voids is n and tetrahedral voids are 12. So shall I write Q are in CCP arrangement? That means the number of spheres, the number of Q atoms are given, that is equals to 4. Now the question is, one more point is here. While P atoms occupies all the tetrahedral voids. So here CCP means the number of atoms in CCP. In CCP, number of atoms, that is n value means it is given 4. Since Q forms P and Q is in CCP, I have taken it as 4. But P occupies, how many P are present? P occupies all the tetrahedral voids. Tetrahedral voids, how many tetrahedral voids are there? Tetrahedral voids is equals to 2n, n is equal to 4, so that is tetrahedral void is 8. So therefore, P is 8. P occupies all the tetrahedrons. So this is the formula to 4 ones are 4 twos. Therefore, the formula is P2Q. The formula of compound is P2Q. What is the note? Atoms of Q are in CCP arrangement, so therefore I have written it is 4. Tetrahedral void is nothing but 8. So P occupies all the tetrahedral voids, therefore it is 8. 4, 8. 8 is to 4 ratio. P to Q is the formula. Let us take second example. Let us illustrate one more. Atoms of B elements, atoms of an element B forms HCP lattice. Next example. Atoms of element B. Atoms of element B forms HCP lattice. Forms HCP lattice, and A occupies, and atoms of A occupies 2/3 of tetrahedral voids. 2/3 of tetrahedral whites. 2/3 of tetrahedral whites. Full stop. What is the formula of compound formed by this? What is the formula of compound? Yes, formula is okay. Directly you can write A and B are the two elements. A and B are the two elements. Correct now? Next, atoms of element B forms HCP. HCP means number of atoms. Hexagonal close pack. HCP means it is 6. So B is 6. That is N value is 6. 2/3 of tetrahedral whites. How many tetrahedral whites are there? 2 times of 6. That is 12. Okay. Tetrahedral white is equals to 12. 2/3 of tetrahedral whites. So A occupies 2/3 of tetrahedral. Tetrahedral white is 2n. 2m. Since n is equal to 6, so tetrahedral white is 2. So this is the formula. Now you can simplify. More on the more 6, 8, 4, 3. So therefore the formula is A4. The formula is A4. A4. Simple enough? Right. Solve one more problem. Next. In a cubic closed pack structure, in CCP of mixed oxide, in CCP of mixed oxides, the lattice is made up of oxide ion. So one structure, mixed oxides are the mixed oxides. In this, the crystal lattice is made up of oxide ion. The lattice is made up of oxide ion. The lattice is made of oxide ions. Next point. 1/8 of tetrahedral whites are occupied by 1/8 of tetrahedral whites are occupied by a divalent ion A+2, occupied by divalent ion A+2, while one half of the tetrahedral whites, octahedral whites, one of the octahedral whites are occupied by B3 plus and trivalent B ion. What is the formula of compound? In a CCP, cubic closed pack structure of mixed oxides, what they have given? The lattice is made of oxide ion. That means oxygen ions makes a CCP arrangement. Tetrahedral and octahedral whites are occupied by ions A and B. So therefore, we can find out the formula of the mixed oxides. What is the formula? A plus 2 ions. B plus 3 ions. So the formula which must should contain A, B, and O, oxygen, because it is an oxide. So what they are given? It is a CCP structure. CCP, that means cubic close pack structure, the number of atoms is 4, FCC. So here oxygen first, CCP. In CCP, number of atoms is equals to 4, it is clear. Tetrahedral is equals to 2n, so therefore it is equals to 8. Octahedral is equals to n, that is equals to 4. These 3 points are clear. Now, ox, A, B, and O. 3 elements are there. Oxygen, the lattice is made up of oxide ion. CCP is the lattice, so therefore the number of oxygen atoms are 4. Next, A. 1 by 8 of tetrahedral voids are occupied by A. That means 1 by 8 of tetrahedral voids. Tetrahedral voids is 8. 1 by 8 of tetrahedral voids are occupied by A. Next, half of the octahedral voids are occupied by. So this is the ratio of ions A, B, and A, B. So the formula is 1, 2, 4. Therefore, the formula is A, B to O4. A, B to O4. Is it clear? Yes, this is about the formula of simple. First step, you need to calculate or identify the number of spheres present per unit cell. Simple. In simple cube, it is 1 BCC, 2 CCP or FCC, it is 4. Hexagonal close pack HCP, it is 6. N values. So by knowing the N values, octahedral voids is equal to n, tetrahedral void is equal to 2n. That is the formula, direct formula. So you can substitute and simplify to get the formula of a compound. Can you solve one more problem? Yes, a solid is made up of 2 elements x and y. A solid is made up of 2 elements x and y. The solid is made up of two elements x and y. 2 elements x and y. So atoms of x are in FCC element. Atoms of x are in FCC arrangement. FCC arrangement. And y atoms occupies atoms of y occupies all the octahedral sites and alternate tetrahedral. All octahedral voids and alternate tetrahedral voids. What is the formula of compound? First, find out L, octahedral, tetrahedral. How many octahedrals and how many tetrahedrals are there? Of course, in this series, FCC. FCC is nothing but n is equals to 4. Tetrahedral voids, octahedral void. Tetrahedral void is 2n, octahedral void is n. That is equals to 8 and 4. Clear? Now, atoms of X are in FCC. So here I have 2 elements X and Y. Atoms of X are in FCC. That means this is equals to 4. Now, Y occupies all the octahedral voids. Octahedral voids are 4 plus Alternative tetrahydroids. How many tetrahydroids are there? Alternative means how many? Half. So 4. So 4 plus 4, it is 8. So 4, 8, 1. The ratio is 1 is x, y2 is the formula. Clear? All the tetrahydroids and alternative tetrahydroids. Alternative means again it's half of the tetrahydroids we need to consider. So therefore 1 is to 2 ratio x and y. The formula of compound. Solve number. If a solid is made up of two elements same x and y, same question, where atoms of element y make CCP, atoms of element y make CCP, made up of x and y. Atoms of element y makes CCP arrangement. Atoms of y make CCP, and those of X occupies all the octahedral all the octahedral wires. What is the formula? Yes, XY direct, because CCP 4, octahedral wire 4. So number of atoms are same. So therefore it is in the ratio 1 is to 1. So formula is XY. If all the atoms of X occupies tetrahedral wires, then what will be the formula? X to y, because tetrahedral wire means it is 2n and it is n. So it is 4, it is 8. 2 is to 1 ratio. X to y will be the formula. So this is about the concept of formula of a compound. Formula of a compound. The next concept is calculations involving unit cell dimensions, particularly calculations of density, molar mass, number of atoms, formula of compound. Take a reading. Next concept, that is calculations involving unit cell dimensions. Calculations involving unit cell dimensions. Calculations involving unit cell dimensions. Density. So here we are going to calculate the density of a unit cell. Density. So already you know the formula. What is the formula of density? Mass by volume. So we can calculate mass of the unit cell, volume of unit cell, and then we can find out the density of a unit cell. So here, to find the density of unit cell, as already been known, or else directly, density is equals to mass of unit cell divided by mass of unit cell by mass by volume of unit cell. So how we are going to calculate the volume? Volume is equals to AQ. In packing fractions we have solved. Volume of unit cell is AQ, where A is edge length. A is edge length. So here mass of unit cell. In place of mass of unit cell, can we write number of sphere into its mass or number of atoms into its mass? If one atom into its mass, that is the respective mass. If suppose 4 atoms are there, 4 into mass of each atom, single atom. What is the mass of hydrogen? 1 gram. That is the mass of Avogadro. Number of atoms is 1 gram, right? So for single atoms, 1 by Avogadro's number into 10 power minus 23. So that is mass of each atom. Single atoms we need to consider. So here, mass of unit cell. In this place we can write number of atoms into mass of mass of each unit cell, mass of each atoms, simple mass of each atom divided by volume of unit cell, that is AQ. Volume of unit cell AQ, where A is edge length. Edge length. So this is the formula. Number of atoms can be taken as Z. Z represents number of atoms into mass of each atom. That means let small m be the mass of each atom divided by AQ. AQ. But mass can be written as mass of each atom. How you are going to find molar mass divided by Avogadro's number? Single atom. Carbon mass is 12. That is for 1 mole of carbon is 12. Avogadro number of atoms is equal to 12. So for single atom, 12 by Avogadro's number. 1.98 10 4 minus 54. So yeah, in place of mass of each atom, can I write m by Avogadro's number? So therefore, density is equals to Z capital M divided by AQ into Na Avogadro's number. So this is the formula of density, grams per cm, grams per cm, centimeter. Where in this formula Z represents number of atoms per unit cell, capital M, it is molar mass, A represents edge length, and A represents Avogadro number, Avogadro's number. Avogadro's number. Now to solve the problems on density, you should know the number of atoms and the relation between edge length and radius. Now, in simple cube, Z, number of atoms in simple cube, BCC, FCC, or it can be written as CCP and HCP is 1, 2, 4, 6. Usually they are putting simple BCC and FCC. And we have derived these things. So what is the relation between edge length and radius? In simple cube, edge length A is equals to 2R. In FCC, face centered cube, right? Face centered cube. Root 2A, 4R is equals to root 2A. 4R is equals to root 2A. Or else A is equals to 4R by root 2. R this can be written as 2 root 2 into A. Correct? Now, in case of FCC, A is equals to 4R divided by 2. Correct? In BCC, A is equals to 2 root 2 R, correct? Because, sorry, face centered, no, it is. In body centered, A is equals to 4R by root 3. Whereas in face center, it is 2 root 2 into R. Correct? Because 4R is equals to root 2 into A. A is equals to 4R by root 2. R is 2 root 2 into R. So we have the relation between edge length and radius. Number of atoms and edge length. This is so. Please note the formula of density of a lines. Density is equal to Zm divided by Aq. Zm divided by Aq into N. Let's solve the numericals on this. Let's take a problem. Element having BCC geometry. Element having first problem. An element having BCC geometry. BCC element. It has atomic mass. Atomic mass 50 U. Calculate the density. Calculate density if edge length of this is 290 picometers. 290 picometers. Density is equal to Zm by Aq Na. So here I want three terms Z, M and A because Na is constant, Avogadro's number is constant. So in this formula given, what they have given data, an element having BCC geometry, that means Z is given. BCC, number of atoms is Z is given. It has a molar mass 50 grams per mole. 50 U, unified atomic mass, that I am expressing in grams, gram atomic mass. 50 grams per mole, it is given, mass is given. Edge length A is equals to 290 picometer is given. So can you convert this picometer into centimeter? How? 290 picometer can be written as 290 into 10 to the power minus 12 meter. Pico is nothing but 10 power minus 12 meter. Now it is in meter. I want to write in centimeter. 1 meter is nothing but 100. So into 10 power 2 plus 2. Plus 2 minus 10 power. This is 290 into 10 to the power minus 10 centimeter. In meter and centimeter I have expressed. Because the density unit is grams per centimeter. Grams per centimeter. So I converted in terms of it is grams and centimeter. And Avogadro's number is Na is equals to 6.02 into 10 power plus 23 per mole. Just substitute these values in the density formula, you will get the answers. Substitution and simplification. Only substitution and simplification. Density. Calculate the density. So here again AQ. I want the value of AQ. Since density is equal to Zm divided by AQ N LR NR. AQ is equal to 290 into 10 power minus 10 cube centimeter. The centimeter cube. So that is 290 into 290 into 290. 290 cube. Into 10 to the power of minus 30 is 10 power minus 30 centimeter. 290 into 290 into 290 into 10 power minus 30 centimeter. This is AQ value. Z is 2, molar mass is 50 grams per mole divided by AQ. 290 cube into Na 6.02 into 10 to the power 23 A cube into 10 to the power minus 30. 290 cube into 10 to the power minus 30. You just simplify this, you get the density. So the density is equals to 290 cube. Final answer 6.81 is given here. You can verify 6.81. It is 100 grams per mole divided by 290 into 290 into 290. 10 to the power minus 30 plus 23 is minus 7. So 290, 290, 290, 6.02 into 10 to the power minus 7, it becomes 10 to the power of plus 7. Plus grams per mole, it is per mole, grams per cm3. Yes, you can see the answer is, it is given 6.81. You can just cross check grams per cm3. Cross check. Density is equal to whether it is correct or wrong. Let's go to the next problem, one more problem. What next? Take one more problem. Copper crystallizes in FCC. Copper crystallizes in FCC. If the radius of copper is, if the radius of copper is 127.8, 127.8 picometer. Radius is given, not the edge length. If the radius is given, calculate the density. Calculate the density of the copper metal. If the atomic mass is 63.5 U, 63.5 U, and Avogadro number is constant. The Avogadro number is constant. You need to calculate the density of crystals. So find out the density. Because copper crystallizes FCC, face-centered cube, it is given. Face-centered cube. So that means you can find the value of Z. Z is equals to 4. Edge length is not given, but radius is given. So you have the relation between edge length and radius. So in FCC, what is the relation? A is equals to 2 root 2 R. Radius is given, substitute and simplify to solve this problem. Density is equals to, and the final answer is 8.94. Verify the answer. 8.94 grams per cm. 8.94. Berlin on the discuss. We'll continue in the next class.